Hello everyone. So I hope you're doing well and swell today. Today's video is going to be more in depth about bare metal C. So this is part two. Believe it or not, I'm actually, um, having a streak in this series. So before I actually get into it, I want to just recommend a few places to check out before you start doing bare metal. The first one is just to get familiar with Arduino. So if you're not familiar with Arduinos or breadboards and just the basics, um, maybe even like get a touch of programming with microcontrollers, even if that has to do with programming with the Arduino framework. There's no problem starting like that. If you want to start like that and then shift over to bare metal, that's totally fine. That's how I did it. And a channel I highly recommend is Paul McWhorter's uh, Arduino series and basic electronics playlist, which I'll link in the description below. I highly recommend watching that if you have not touched an Arduino before or have no idea what a microcontroller is. He goes from the basics. I mean, it really explains very well. He's a great person. He talks very clearly and goes step by step. And at the end of his playlist, you will actually get a very good knowledge of how electronics work. So it starts off very easy, very straightforward, and you end off in a very strong place. Of course, all of that using Arduino's framework. And then afterwards, because you have that good foundation, you could just switch over to bare metal. If you have never even programmed in the C-esque language types, so just languages that are kind of in the same syntax as C, C++, then I recommend over to freecodecamp.org's YouTube page. They have hour-long videos that go over the core concepts of C, C++ programming. This has nothing to do with microelectronics or embedded systems programming. It's just to get an idea of how to program in C, C++. I started learning C, C++. So I first learned the programming language, Python, but I really wanted to get into electronics. So I learned the Arduino framework of C. So I recommend going over to freecodecamp.org. I'll link them also in the description below. So I'll link both of them in the description below so you can check them out. So in today's video, it's going to be kind of straightforward. So what we're going to first do is we're just going to open up a new window on Visual Studio Code. I'll make a separate video probably just to, how to install Platform IO with Visual Studio and all that. But in this series, I'm just going to focus on programming in bare metal, but I'll also just kind of navigate you in the beginning on how to work with this. So what you want to do, first off, is I'm assuming you'll have Platform IO installed. If you don't, it really is just by searching here Platform IO on the extension in the marketplace. You click this first one, and then you press install here. So normally this would be install. For me, it's uninstall since I already have it installed. And you have over 600 different types of microcontrollers to choose from. So you really have a large library to choose from. You can install your libraries just like you would with the Arduino IDE, and also you could choose your boards. So that's what you can do with the Platform IO IDE. So I'll go over to Platform IO. So it's this little icon here, and I'm going to make this full screen so you can really see what's going on. And I'll go here, and I'm going to press Create New Project. And this will bring you to the Platform IO homepage. So you'll look at something like this, and you want to press New Project. So up here, you're going to just call it whatever you want. I'll just call it blink, or not blink, just LED underscore example. And okay, look at that. There's 1,500. So I was way off. It's more than I expected. Go here and select your board. I'm gonna choose the Arduino Nano Atmega 328P new bootloader. Now, if you have a Chinese knockoff, or really any knockoff other than eLego and some other brands, obviously the official Arduino Nano as well is new bootloaders, but usually the ones you would get from AliExpress do not have the new bootloader. So that's something you want to also check out for. There isn't really a good way of knowing. If you get it from Amazon and the company is called eLego, that's where I got mine from. They're definitely more expensive, but they do come with a new bootloader. If you do not have the new bootloader, then you have to press this one. This one will automatically be as the old bootloader. So for this case, I'll just select new bootloader. You can always change this afterwards in the initialization file, which I'll show later. For now, the framework will be Arduino like this, and then afterwards you could just choose not to use the Arduino framework. Then after that, you're just going to press finish. And this might take a few minutes. All right, so the project is now open. It's a fresh project. And right away, you're welcomed in the initialization file. So this is where you kind of choose what microcontroller you're using. In this case, it says ENV for environment, Nano Atmega 328 new. So this new is for the new bootloader. If you have the old one, all you have to do is just remove these last 3 letters and you get the old bootloader. And when you save this, it actually updates your entire project and you don't have to do anything. That's all you have to do. If you have the new one, just keep this here. Okay. Next, you have these folders. Now, for the time being, we're only going to focus on the source and include. Okay. For this video specifically, we'll only be in the source. So in the source is where your main is located. And right away, you're given a template on just an example of C++ functions. This file is called C++, so I'm going to just say that this is C++ code. Now, this will remind you a lot about the Arduino's IDE syntax, or rather the Arduino framework syntax. And what I'm going to do is I'm just going to remove the my function, and I'll also remove this up here, and I'll also remove this Arduino.h. So what I'm doing now is I'm just cleaning up the main.cpp, and what I'm going to do is I'm just going to reformat the whole thing so that it's bare metal C. Now, since we want to do it in bare metal C, this cannot be named C++. It can, but we want to just program in bare metal C. So what I'll do is just right click this, go on rename, and remove the last 2 P's. Now this is a C file. What you also want to do is actually get rid of all this. So at the end of the day, you actually want to get rid of everything that comes in the file, because that's not what we want to use. So we've just cleaned up the main, and the first thing you always want to have is your standard files. So your standard files, or the standard library files, will be a set of libraries that are required in order to actually do bare metal. These are things such as integers, Boolean values, and input-output libraries, especially from the AVR library. Now, the first one, which I think is quite important, is the standard library for integers.h. The second is your standard library for Booleans. The third is your AVR input output. Yeah, you also have your interrupt file. And I'm going to write all these down. Actually, that's pretty much it, just to get things started. You could also just include math if you want to do arithmetic, but this is optional. You do not need this for all your projects. Okay, so You always want to make sure that you have these in your files, especially in the source files. Now, in the Arduino IDE, you're going to be used to seeing void setup as well as void loop, right? This is something very common. It's going to happen. You're going to see this in every single Arduino project. You'll always have these. This is your high frequency loop, meaning that your program will loop in this function here, and all your initializations will occur here. But in bare metal C, what you're going to have is an integer. So you're going to have a function, main, that returns an integer. And inside of this function, you're going to have a while loop. And inside this while loop, you'll just have 1. And that's it. You can also just put return 0 here. But this is the framework for your code. Now, you may look at this and be like, hey, that's a bit weird. That's a little strange. It looks kind of off. Where are my setup? Where's my loop? Well, your loop is happening here, right? This will loop because it's always true. So this is your void loop. So this is your void loop. And anything above this or outside of this while loop is your setup. So we've just, right now, all we've done is created an outline of where we're supposed to put our code, especially for those who've already done Arduino programming. Then you will already know that, okay, well, I just put all my functions, my high frequency functions in here, and all my setup functions in here. Okay, great. Before we set up the breadboard to just turn on an LED, I want to show you some key things that you have to always have next to you when you're programming bare metal C, and that is schematic pinout sheets and data sheets. So the pinout for an Arduino Nano is relatively simple. So all you have to do is open up your Chrome browser or whatever browser you want, and you search up Arduino Nano pinout. And when you do so, you're given, you have a bunch of links. What I like to do is just go on images, and you're given a bunch of pictures. And the one I really like, and I believe it's this one right here, it's the one like this. It has very nice information like this, and it shows you all the pin names, all of their functionalities, all laid out very nicely. So I'll just click this, and you're going to go to a site, probably an article. This is from TechSparks. And what I do is I go here, open image in a new tab, and you have the pinout right in front of you. This is the full pinout for the Arduino Nano. Now, it's not very detailed. It's not too detailed that there's too many things on the screen, but it does give you almost everything so that you program it properly. And there's a lot of information here for those who have not seen the pinout, and I'll go through it step by step as we go through the series. And for those who are already experienced in Arduino, well, you might have already seen this, but actually getting to know the functionalities of, what this means, what does this turquoise, what is this SDA, SCL, we're going to get into all of that. Really, and when I mean we're going to get into all that, I mean we're really going to dig into the data sheets and what they mean and actually how to access it without using any external library. So it's going to be very hardcore. All right, so this is the Arduino's pinout. So this is what we call a pinout. Now, for the Arduino's data sheet, you're going to create a new tab, and you want to search up Arduino data sheet, or rather, actually, it's the microcontroller. So we're going to search up @mega 328p data sheet. This will usually always reference the creators of that chip, in this case, microchip. And we're going to click it, and it's going to bring you to a document like this. Now, some documents are more updated than others. So if I press this one, it's 662 pages, while the one before is 294 pages. Now, the reason is simply because this document only focuses on one model, while the other focuses, as you can see, on many model. So you can choose this one if you want, or you could choose this one. In both cases, you'll just want to look for your model of microcontroller, and you can just go through it. You can skim over it, and you'll have diagrams like this, which may be familiar to you if you're a computer engineering student or software engineering student. And it has pretty much everything you need regarding the microcontroller. Now, what I like about these documents is that not only does it show you information regarding your microcontroller, but it also shows example code that is bare metal, right? This is C code. You also have AVR documentation, the size of your flash chip. This is how your chip is going to store memory. So all of the code that we actually upload to the chip is stored here in this section, and the bootloader is in here. So this is a diagram showing that. And as you can see, very useful information, things that'll come in handy as you start programming and go in depth. So now that we know this, our goal is to turn on an LED and then just turn it off. So there's no delays and it's not going to be automatic. So I just want to have a single state situation. Going back here, what I want to do is choose a digital pin. Now, for the time being, I want to choose a pin that has one of these squiggly lines so that we're consistent with code that we're going to do in the future. I don't want to use different pins. So I want to use a pin that has different functionalities, and so that we're consistent with it. Now, for your time being, I just want to explain that the ones that are just lines like this are simply digital pins. These are pins that are only high or low, while these ones with lines that are going like this are what we call pulse width modulation, or PWM pins, or PWM active pins. So these pins are not just 0 and 1s. These pins are actually 0 to 255 and integers between 0 and 255. What does that mean? That means that you can actually vary the amount, the signal's output from 0 to 255. Essentially, you're controlling the brightness, right? If it's an LED, you're controlling the brightness. And if you're controlling other things, well, it's the signal, right? And we're going to do all that. We're going to do PWM programming. So what I want to do is maybe I'm going to just choose, let's hear D9. D9 has a very simple set of functionalities. It has what we call pulse width modulation, but it also has digital high. So see, it has a line going through it, but it also has pulse width modulation. So it's both, and you have to define that, which we will. And the pin name is PB1. Now, PB1 means that it's the port in group A, bit number 1. That's what that means. So you've probably seen this before and you were just assuming that it's just a name. And that's true, it is just a name. But the actual definition is that it's the port in group B, bit number 1. And if you're going to do pulse width modulation, this is the register name that you're going to be touching. So this is where you're going to set from 0 to 255. Now in this video, we're just going to turn on an LED. So I'm going to go back to Visual Studio. And you can actually print that pinout that we had before. And, you can study it. You can go through it, look at the different pins. I have it on my second monitor right now. So I'm always going to be looking at it during the whole series. Okay. I'm just going to put up my second monitor. Okay. So in Arduino, you have, I believe it was called pin mode, right? You have pin mode, and let's say we had PB1, and it's an output. So this is how you would define a output pin on the Arduino framework. Now, what is the problem with this? Well, it's a function call. You see, we're passing the values PB1 and output to the function called pin mode. Probably, somewhere in the files, the many files that the Arduino.h file has. So we don't want to do that. What we want to do instead is just program it in bare metal. At first you might be, oh no, that's going to be too complicated. But look at this. The first thing you want to write is your data direction. So DD. Data direction what? The register. And you're given these options here. You're given B, C, and D. Okay, well, that's exactly what the Arduino Nano has, right? It has PD, it has PC, and it has PB. And because our pin, recall, PB1, that means that it's port in group B, bit number 1. So what we choose is data direction register for group B. Now here, what you do is you do a bitwise OR operation. So you put a vertical dash, okay? I think that's what that's called. I could be wrong. But you put this vertical bar here and you set equal. And then you do the bitwise operation to PB1, semicolon. That's it. What you've just done is that you set PB1 as an output. And I'm going to explain the math in detail now. So the bitwise OR operation that occurs here, and by the way, this line can also, right, be written as equal to DDRB or 1, right? Because all we're doing is we're taking this and we're placing it before. And this is going to come in handy, right? This format will come in handy when I'm going to explain. So what's happening here? So we're doing a bitwise OR operation between DDRB and whatever this is, right? And I'm going to explain to you what this is. This is setting the bit from group B at position 1 to 1. So what does that look like? That looks like something like this. This is what the register looks like. And DDRB looks like this, but there is no 0, right? So it's like this. This is what it looks like. And in the middle, you're doing the OR operation. So when you put this, I'm going to translate this line to the equation I'm going to write. So it looks like this, right? It's recursive. So you're doing this bitwise, you're ORing it with this, and the output is just this, right? Because you have in this position a 0, and this position a 1. And if you do 0 or 1, well, it's going to be 1. So this is what you're going to be having as DDRB for PB1. So in group B, this is PB1. This is what PB1 means. It's group and it's bit number 1, because this is bit number 0. Don't forget, this is bit number 0. We have PB0. PB0 is a thing. So this is PB1, and you may have guessed it, this is PB2, this is PB3, 4, 5, 6, and 7. So that's what this line means. So that's what this lines mean. Okay. So we've just set it as output. Nice. Now let's turn on the LED. So how do you write this? So this is, instead of it being DDRB, you're going to call it port B. So port B, like this. And what you're going to do is you're going to do this exact operation here. You're doing an OR and you're putting that as high. So here we did an output and here we're doing it as high. This will turn on your LED. Okay, that's it. It's exactly the same as digital write PB1 high. But instead of relying on this function call, which we saw in last video, had a bunch of lines that we didn't need, it all is reduced to this. Now I'm going to head over to the breadboard and just show you what circuit I'll be using to actually compute this. And I've done is I've just taken P to D9. So here it's called D9, but the pin name is called PB1. And I've connected it to the anode of the LED. So here's just a green LED. I've connected to the anode, and the cathode is connected to ground. And this is a 330 ohm resistor. And that resistor is connected to ground. So from here, it goes to ground, okay? And then this rail is just connected to this rail, so this is grounded. And if you're not sure what the cathode and anode means, the anode is the positive leg, which is the longer leg, and the cathode is the shorter leg, right? The negative leg. And it's a diode, so if you just don't put it the right way, it's not going to turn on. So we're going to resist flow. So this is the circuit, a very basic circuit. It's one of the first circuits you'll learn when doing one of these, Arduino projects. It's just to set up an LED. You can use anything from like 200, even 150 ohms, all the way up to like around 700 or 800 ohms. Obviously, the higher the resistance, it's going to resist more current, so it's going to be less bright. So I just chose 330, which is a very common value when using LEDs. So I'm going to switch back to the code to just show you how to upload this code. There you go. So I've just connected the Arduino Nano to my computer. And what's nice about the software, it'll automatically detect it. So if I go down here, it says auto. And if I press it, it'll actually, you'll see the COM port that it is indeed connected. If you don't see this, there might be a problem. You might have to disconnect your Arduino Nano and then reconnect it. In my case, it's called a COM18. So I can either select it like that and you'll see it's set to COM18, but I like to also just have it at auto because if you're switching USB ports, well, you want it to automatically connect to that port. So what we could do first is instead of uploading it, we could just compile it using this little check mark. It's called build. So this is the same check mark you would see on the Arduino framework or the Arduino IDE. So I'm just going to press this. You'll see things running here. And there you go. Success. Success. And look how little it used. 0.4%. I can bet you my bottom dollar, if you were to do this using just digital write and pin mode, it would be a few percent. It will definitely be above 1%. But even though that doesn't seem like a lot, it is a lot. When it goes over time, it accumulates, right? If you're going to have complex code with many files, you actually want to have hardware that can handle your code. And especially when it comes to microcontrollers, you're not given a lot of memory to use. So you really want to always optimize that code, and Bare Metal C does that for you. So because that was, we were able to build it, I'm just going to press upload. So I'm going to press upload. It's going to connect to the same port. And there you go. Now I'm going to switch over my camera. And you can see the LED, by the way, is much brighter now. I mean, it's just on at this point. And this means that our code worked. Now I'm going to go back to the code. And instead of having this, I'm going to have the and I'm going to put a tilde. Now I'll get into this a bit in some more depth later. Oh, which one is my tilde? There you go. I wasn't sure on my keyboard because this keyboard is a 70% keyboard, so it doesn't actually have a dedicated tilde. But anyways, as you've guessed, this is also a bitwise operation. This one does an and a negation. So logically, it's going to clear that bit. So if I upload this and I switch to my camera, and there you go, turned off. Wow, would you look at that? Some real science, isn't it? So we were able to, in this video, turn on an LED and also turn off using pure C code. So there was no function calls that happened. The only thing we used were standard libraries so that our software actually just knows what pins we're using. And that's the same thing as selecting your board in the Arduino IDE. We were also able to use bitwise operations. We set up from scratch our C file, our main.c. And in next video, what I'm going to do is I'm going to start implementing our delays or our bitwise operations to blink an LED instead of just manually turning it on and off. So I hope you enjoyed this video. You can leave a like, subscribe, comment down below what you think, what you want to see in the future in the series. And I just hope you like it. Thank you.